Suppose a state has a $31 billion budget for K through 12 schools. If that money is dispersed among 292 school districts throughout the state, how much money will each school district receive? All right. The first thing you're doing thinking about this problem is trying to decide, are you multiplying or dividing? Well, when you look at this, we're trying to figure out how much will each. So we're splitting it up into each one. As soon as you think the word split, divide, disperse, we're talking about a division problem. So we're talking about money per school district. So the money is $31 billion. School districts, 292. When you're dealing with big numbers, generally scientific notation is the easiest way to do it. So remember that billion means 9. So this is 31 times 10 to the 9th. Well, that's not scientific notation. Recall, 31 is big, so if I move this over 1, my exponent's going to go up by 1. So that gives me 3.1 times 10 to the 10th. Down here, I move it 2 places over, so I have 2.92 times 10 to the 2nd. And now I can divide. I divide my numbers here, and I end up with 1.0616. I rounded. I subtract my exponents, so I get times 10 to the 8th. And when we're talking about money, you don't talk about, oh, I have 1.0616 times 10 to the 8 dollars. No, we talk standard form. So I'm going to change this back to standard form by moving my decimal 8 places. 1, 2, 3, 4, meaning I'm going to add 4 more places of zeros. And each school district is receiving approximately $106,160,000. Problem number 2. According to a 2013 report from the U.S. Bureau of Justice Statistics, approximately 2.2 million Americans are incarcerated in local jails and state and federal prisons. If it costs $25,000 to house an inmate for a year, approximately how much is U.S. spending on incarcerations yearly? Key here, per inmate. We have this many inmates, and it's this much per inmate. So we're going to say 2.2 million inmates times $25,000 per inmate, right? We know our number is going to get bigger because it's costing a lot of money. So let's go ahead and change these to scientific notation to make that easier. Million means 6, so times 10 to the 6th. 25,000, I want my decimal point to be here. So that was 1, 2, 3, 4 places. So now I'm dealing with the blue problem. If I multiply my non-powers of 10 numbers, I end up with 5.5. And then since I'm multiplying, I add my exponents and I get times 10 to the 10th. Now again, we're talking about money, so I'm going to go ahead and change that to standard form. 10 places, so 1 means I'm going to have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which gives us roughly $55 billion is what we spend on inmates in a year. Approximately. It's estimated that a single droplet from a sneeze can contain as many as 200 million germs. That's gross. If a sneeze is composed of 40,000 of these little droplets, how many germs are in a single sneeze? Okay, so one droplet has 200 million germs. A sneeze has 40,000 droplets. So again, we're talking about this getting just huge. So I have 200 million germs times 40,000 droplets. Well, a million is 6, so 200 times 10 to the 6th. But I need to move that over, so my exponent's going to go up by 2. So this is 2 times 10 to the 8th, right? Because 200 is the same as 2 times 10 squared, and 2 plus 6, right? That's where that comes from. And then this, I move my decimal 4 places, so that's like times 10 to the 4th. Very similar to problem number 2. I multiply my non-powers of 10 numbers. 4 times 2 is 8. I add my exponents to get times 10 to the 12th. And hopefully you remember that 10 to the 12th means trillion. So this says there are 8 trillion germs in a single sneeze. Ooh, gross. Number 4, according to its website, Lucas Oil Stadium in Indianapolis holds approximately 70,000 spectators. How many stadiums would it take to hold the entire U.S. population? Now, if you go back to our previous video, the U.S. population referred to there is approximately 325,700,000. So this is how many people. We want to split that up into as many Lucas Oil stadiums as we can. Now, if you have two numbers in standard form, you can go ahead and divide those. Go for it, right? So it rounds to be approximately 4,653 stadiums. But I'm going to go ahead and show this in scientific notation because that's how we roll. So the top number, I would move it 8 places and 3.257 times 10 to the 8th. And in the denominator, I'm moving it 4 places, so that's 7 times 10 to the 4th. Now, when I divide the front piece, I get approximately 0.4653 times 10 to the 4th. Because again, when I divide, I subtract my exponents. Now, if I want to move that to standard form, I'm going to move my decimal 4 places, 1, 2, 3, 4, which gives me 4,653. So you see you get the answer the same either way, top or bottom. Just depends what kind of information you're given. Sometimes it's easier to do it one way or the other. And number 5, a meme on social media was divvying up lottery winnings among everyone in the country. If the jackpot at the time was roughly $1.3 billion and the meme estimated a population of 300 million, how much would each person win? Okay, so we're talking about money per person. So we've got 1.3 billion over 300 million. Now, I'm going to show you a kind of a different way to do this problem, so bear with me. Okay, so we talked about how billion is 9. We know that. So I have 1.3 times 10 to the 9, and million is 6. So this is 300 times 10 to the 6th. Now, up to this point, we've said, well, 300 is not in scientific notation, so we should change that. Well, watch what happens if you don't change it. If you just say, hey, I have some numbers, non-power of 10 numbers and power of 10 numbers. If I divide these two non-power of 10 numbers, I get 0.00433. Then I subtract my exponents and I get times 10 to the 3rd. Well, we're talking about money, so we're going to change this to standard form anyway. I'm going to move my decimal 3 places, 1, 2, 3, and we end up with $4.33. Now, if I had changed that, this was billion, and we had this in million. If I move this over, right, 2 places, that means this goes up by 2. I get 1.3 times 10 to the 9th over 3 times 10 to the 8th. If I divide that, I get 0.433 times 10 to the 1st. Okay, well, there's still a first, so I move it over 1 place, and I'm still left with $4.33. So you can see that whether you divide them as they are, or you change them, come on, buddy, change it to scientific notation first, ultimately you'll get the same answer, assuming you do your math correctly. And that is applications of scientific notation.